All right, we're going to start the Zoom meeting, Math 1113, Tuesday, November 24th. And we have a participant. I can't see who you are. You want to tell me who you are?
It's Michaela.
Oh, okay. Very good. Appreciate you coming out this morning. Did you have any questions?
Give me just a second. I'm trying to find my math sheet. It's on my desk.
Okay.
The only one I really have questions on is sex.
You mean problem 6?
Yes, on the
Okay.
study guide.
Okay. 4, 5, 6. Okay. All right, you want me to go ahead and go over that one?
Yes, please.
All right. So, given stuff 1113 final exam review, that a sine of t 1/4 secant of t negative, which means negative. Find cosine of 2t. All right. Just to remind you, do you remember your formula for cosine of 2t? There were actually 3 of them. I guess we'll use the first one, cosine squared of t minus sine squared of t. You remember that?
Yes, sir.
Okay. So the trick is to draw a triangle into the correct quadrant and figure out what the cosine of t is. We already know the sine of t. We can actually plug in the negative 1/4 right there for sine of t directly. So we got to figure out the cosine of t off of this. All right. Your secant of t less than 0 also means your cosine of t will be less than 0. If you flip them, you're still less than 0. So that's going to say quadrant cosine of t says that's your x coordinate. That's quadrants 2 or 3. 3. All right, and sine being negative, that's your y coordinate being negative. If sine of t is negative, that says quadrant 3. You see the logic to that?
Yes, sir. All right. That's what I was struggling on, was the graph part of it. So.
Okay. So yeah, basically both your x
coordinate for me.
Yeah, both your x coordinate and your y coordinate are negative, and that only happens in quadrant 3. So we can now label this as opposite over hypotenuse. So we can put -1 on the opposite, 4 on the hypotenuse. And then your x leg here, I don't know if you need to see the algebra, x squared plus your -1 squared equals 4 squared. So x squared plus 1 equals 16. X will equal 15 when you subtract 1 over, and x squared will equal 15. X will equal plus or minus the square root of 15. And you can see from the picture, we're going to want it negative. X will equal negative root 15. And this tells us that the cosine of t then is adjacent over hypotenuse, negative root 15 divided by 4. Are we together so far?
Yes, I'm good.
Okay. So now it's just plug and chug into that to figure out the cosine of 2t. Take cosine of t, so that's negative root 15 divided by 4, that's squared, and subtract negative 1/4 quantity squared. And so that'll give you a 15 over 16 and minus a 1 over 16. That should be 14 over 16, reduces to what, 7 over 8? I hope that's what I had on my key. Double check it. It is.
Okay, that's all I had for that one. So thank you. I think that's the majority of I think that's the only one I really had issues with on the study guide. So
Okay. Well, you're welcome to stay around. If you got better things to do, no problem. Only 6 minutes in, so I need to work a few more to convince my bosses over there that I'm actually earning my money. So I may just charge in on problem 1, 2, and just kind of work them in order. And so feel free to hang around, or if you got other things to do, it's no problem.
all right, thank you.
Sure thing. All right, let's see. So charge into problem 1. And it's the 1113 review. Problem 1, you're given cosecant of theta. They tell you flat out theta in quadrant 2. I want you to fill in the table. Fill in sine theta, cosine theta, tangent theta. I'll give you blanks for these. And then flip them. And you already know this blank, that's 2. Secant, tangent. So quadrant 2 picture look like this. Sine of theta would be a half, it flips, so there's 1/2. Opposite over hypotenuse. You tell your x squared plus 1 squared would equal 2 squared. Plus 1 would equal 4. Would equal 3. X would be plus or minus square root of 3. And once again, we'd want negative root 3. All right, should be able to fill it in. Your sine theta, I just wrote it down, that's a half. Cosine would be negative root 3 over 2. Secant would be negative 2 over root 3. And your tangent, sine divided by cosine, or you can do it right off of here, off the triangle, opposite over adjacent, 1 over negative root 3. You can also write negative 1 over root 3. It doesn't matter which level you put the negative. Over root 3, and that makes cotangent negative root 3, and you don't have to write it over 1. All right, hopefully these are pretty familiar to you by now. Number 2, evaluate sine 11 pi over 6. Well, that's going to be in the 4th quadrant because you're just short 12 pi over 6, which is equal to 2 pi. So you're going to be pi over 6 short of 2 pi. Sine is this leg, and it would be a negative a half. Your coordinates would be root 3 over 2 positive, that's your cosine, and your y coordinate would be negative a half. Reference pi over 6. All right. 3. Okay. 3a. X, this is 45 degrees and this side's 20. And B, you're at 30 degrees. This is 30 and you want X. Okay, so tangent 40, I'll work it out on the key. I took advantage of the special angles. At 45 degrees, legs are equal. But if you want to work it out, be X over 20, opposite over adjacent. Multiply both sides by 20. Tangent at 45 degrees is 1 times 1 equals X, so X equals 20. And again, it just shows that at 45, your Y leg has risen to be equal to your X leg. If you want to stick it in a circle, you can make it in a circle. That's supposed to be at the origin. All right, at 30 degrees, this would be a sine. X over 30. Multiply both sides by 30. And working it out, and at sine 30 degrees, you're at a half on the unit circle, which means your 30 times a half equals 15, which equals your X. At 30 degrees, your Y leg is, even though we've called it X, just a generic triangle using an X for an unknown like in algebra, but at 30 degrees, your vertical opposite leg is half your hypotenuse. Write that out. The opposite leg, we'll call it opposite leg, usually it's the Y leg, is half hypotenuse. At 45 degrees, legs, which means X leg, Y leg, are equal. All right, we'll just keep working through here. Given leg's 8, this leg's 15, and find cotangent theta. Well, tan would be 15 over 8, opposite, it's supposed to be right, opposite over adjacent, so your cotangent's the flip, it would be 8 over 15. Okay, number 5, given cotangent of theta is a quarter, and your sine theta is positive. This means your Y leg. See if we can puzzle out which quadrant that's in. Got to have a positive cotangent. Your tangent is 4 over 1, if you want to see it. And Y leg is positive. All right, tangent's going to have positive, tangent positive in 1 and 3. Sine is positive in 1. So this is quadrant 1. Your sine would be negative down here. Your tangent works out positive down here because your Y leg and your X leg are both negative. Divide them, they turn positive. So if the tangent, if your sine's positive, you got to pick the quadrant 1. All right, which means tangent theta is 4 over 1. Means your Y leg's 4 times your X leg. Your hypotenuse, call it R squared then is the square root. R squared is 4 squared add 1 squared, so R is 17. R would be the square root of 17. You only need a positive. We're supposed to find sine of 2 theta. Hopefully you remember that is twice the sine of theta, the cosine of theta. And now it's plug and chug. I haven't written down the sine twice. Your sine is, this is r squared is r. The square root of 17 is square, let's see, the sine is 4 over root 17. Cosine is 1 over root 17. And so you have 8 over 17. 2 times 4 is 8, root 17 is 17. Okay, just keep working right along. We've already done 6. That was the first problem our participant asked for. So it's very beginning of the video. 6, beginning of video. 7, verify cosine of x over a secant, sine of x over a cosecant comes up 1. Well, I'm going to convert sines and cosines. So a secant, cosine, and a cosecant, 1 over sine. So I get cosine sub in 1 over cosine of x, sine of x over 1 over sine of x. Divide these out, you get cosine x times cosine x over 1 plus sine x times sine x over 1. And can you tell, sure enough, a cosine squared of x plus a sine comes up 1. Most of the time we write that in with sine squared first, but hopefully that doesn't bother you that it switched. All right. Number 8. I guess we're not making you memorize these formulas. This given in this problem that a sine of a sum, sine of first, cosine of second, add cosine of first, sine of second. We stick in a minus sign. Sine of first, cosine of second, minus cosine of first, sine of second. So we're going to verify that a sine of pi over 2 minus x, the difference of pi over 2 is exactly identical to sine. If I take pi over 2 and add a number. So don't get confused. This is like my x, this is like my y. Just think first and second. That's the easiest, no matter what they call them. This is first, and this is second, this is first, and this is second. So this side's going to follow this one because of the minus sign there. That will make sine of first, cosine of second, minus cosine of first, sine of second. So that's how that one expands out. This one's going to follow the top one because of the plus sign. Sine of first, cosine of second, cosine of first, sine of second. 1, so you get a cosine of x. A Cosine of pi over 2 is 0. Hope everybody knows this. Do I need to draw out the circle? Pi over 2, you're up here. Coordinate is 0, 1. Cosine 0, sine is 1. Angle of pi over 2, 90 degrees. So minus 0, and on this side, sine of pi over 2 is 1. We get a cosine of x. Cosine of pi over 2 is 0 plus 0. And sure enough, cosine x is equal to cosine x. They both work out cosine x. So bottom line, you can take pi over 2, subtract any number, and take pi over 2, add, subtract any, and add any number, and take the sign on that, and you get the same thing. You can punch it on the calculator and prove it as well. All right. Number 9. Secant of arc sine 12 over 13. So you want to label this according to the sign, opposite over hypotenuse. Opposite over hypotenuse. Can you tell this leg is 5? You're familiar with a 5, 12, 13 right triangle. Work it out. I'm going to call it x. 12 squared equals 13 squared. X squared would equal, or x squared plus 4 equals 169. Would equal 25. Subtract and get 25, and x is 5. Don't need plus or minus, so it's not a coordinate. If it was coordinate, I'd have to pay attention to plus or minus 5 and which coordinate is it in, and is it positive or negative. But on a triangle, we just take it to be positive. And so can you tell your cosine would be 5 over 13. Your secant is the flip. Secant of this 13 is 13 over 5. Okay, try again on a fresh sheet. Let me bleed this up. It's on the key. Okay, 10. Secant squared of x minus 4 equals 0. We can solve it on 0, 2 pi. Solve. All right, so cosecant squared x would equal 4. Sine squared of x would be 1/4. Flip. X is plus or minus square root of 1/4. Sine of x then is plus or minus 1 over 2. Okay. So split it up. Take 1/2. And again, on 0 to 2 pi, can you tell your x is going to be pi over 6 and 5 pi over 6? If you need to see it drawn out, it's basically 30 degrees. Coordinate is, we care about the y coordinate 1/2. And the other place you have the same y coordinate, 1/2. With pi over 6 reference, which is pi over 6 short of pi. If I take sine of x negative 1/2, I'm in the other two quadrants with a pi over 6 reference. Negative 1/2. So I'm pi over 6, next we're solving for x. I am pi over 6 short of 2 pi, that'd be 11 pi over 6. And over here, again, with the y leg negative 1/2, pi over 6 bigger than pi, that would be 7 pi over 6. Okay. $11. Solve cosine of x minus 0.4 equals 0, again on 0, 2 pi. That would give us twice cosine of x equals 0.4 divided by 2 equals 0.2. First cut at it, your x would be the arc cosine of 0.2. Want radian mode. .3694. Y'all remember what that looks, because you get the second one, you got to interpret it. All right, remember this is the x coordinate. And this is your angle. In the first quadrant, 9,4 with an x leg of 0.2. All right, the only other place you're going to get a positive x leg of 0.2 is down here. This reference is 1.3694. And so your other angle is going to be 2 pi minus 1.3694. 2 pi minus 3694. 4.9138. You can check this. If I take the cosine of 4.9138, it better come up somewhere close to 0.2. Cosine 4.9138. Pretty sure radian mode. Didn't check that was in radian mode. Got lucky, I guess, there. And yeah, you're at 0.20052, etc. So that's one way to check. Sketch a graph. Cosecant of 3x, you would enter 1 divided by sine of 3x. Period is 2 pi over that coefficient, 2 pi over 3. Remember this, we call this the k value, period, 2 pi over k. Remember, I don't know if I need to remind you, that worked for cosine, cosecant, and secant, period, pi over k on tangent, cotangent. Draw a graph of this. One divided by sine 3x. Window, I guess we'll go with that. 10, 10, 1, 10, 10, 1. Don't need to show the graph. Yeah, if I put on sine of 3x, shift it off the y-axis, you get these series of u's. It doesn't really go through the origin like I'm showing it. Well, maybe it does actually. Yeah, I guess it does. Yeah. Sine would go through the origin. You can, if I put on sine 3x. Yeah, you can see, yeah, it goes through the origin. And then each of these humps and dips flip you get a vertical asymptote through each x-intercept. Dip flips down. The point at the dip or the peak is identical because that's where your sine's 1, so you flip it and your cosecant's 1. You get another one this way. Asymptote, doing this, etc. All right, graph. Tangent of 2x, and once again, your period pi over that k value. This k is this coefficient, and that would be pi over 2. Clear this off, and you want a tangent of 2x. Get the series of S curves. Just draw the first 2 or 3. The origin. Etc. Y and x. Secret is though you want to be in radian mode. Y equals 2 cosine of 3x minus 1, add 4. We want to find all these things: amplitude, period, phase shift, vertical shift. Oh, the parentheses closed here. Sorry about that. Vertical shift. Just going from the easiest to the tougher ones. The vertical shift is 4. Amplitude at the front is 2. Remember, don't forget its absolute value of this. It's always positive, always positive. Golly, where all that stuff's come from. Always positive. Period is 2 pi over this coefficient, which is 2 pi over 3. All right, so those are easily knocked out. Phase shift. You want to write with k factored out. 2 cosine, factor out the 3, and you're left with x minus 1/3. 3x and then minus 1. Your phase shift is going to be 1/3. Again, it's negative in the formula, but it's a positive number out there. Okay. Five minutes. 15. Uh, 50 degrees, 30 degrees, 100 degrees. Checks out. 150, 30, 180, yeah. Okay, x there, 2 there. Line x. So we can play at law of sines. X over a sine of 100 degrees. Remember, any side over the sine of its opposite angle is equal to any other side over the sine of its opposite angle. We multiply both sides by a sine of 100 degrees. Sine 100 degrees over sine 50 degrees. These cancel. Now you want degree mode. These kind of problems work in degree mode. Unless you want to individually convert the angles, which we don't really want to do. So twice 100 sine 50. 2.57. All right, let's see, 16, 411, 314, and 104 degrees. This is a classic side angle side problem. Use law of cosines. Remember that scheme, x squared, the other two sides squared, twice times those two sides, cosine of the angle opposite the side you're using. And again, you will want, so it's a more general Pythagorean theorem. You can see the square, 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 but you got this correction term because it's not a right triangle. Hope all this stuff is familiar to you. That's why we go over it again, to try to drive it into your brain. Pretty sure we threw it in degree mode. So we want 411 squared, 314 squared. That was 314 squared, yeah. Subtract 2 times 411 times 314. Cosine 104. 329, 958.9766. That's x squared. So we're going to want the square root. 574.42. Now I'll take that answer if you want to be hyper-technical with the book. We only want integer accuracy. You only have to report answers to the accuracy of the problem, which is integers. So we would also take just 574. All right. We're not going too fast, trying to squeeze this in and I'll resume. Back way to the beginning, 17, beginning of trig anyway. Second quadrant, this is 45 degrees there, 12 on the radius. And we're trying to do the arc length. S equals arc length, find S, theta, and that would be 12 for the R equals 12. Theta is 135 degrees. You got 90 here, plus your 45 is 135 degrees. But you remember, it's got to be in radians. So we're going to multiply by pi over 180 degrees. It'll be 3 pi over 4. Off the circle, so we've got 12, 35, pi, 180, 28.27. All right, then the last three, we go back to logs and exponentials. They were off of chapter 4, very at the beginning. We got just enough time to squeeze them in. X, a log of x, add a log of x minus 3. is it 1? So log of x minus 3 equals 1, because he's combined, multiplied the two arguments. Base 10 to a log of x minus 3 equals 10 to the 1. X minus 3 then equals 10. Minus 3x minus 10 equals 0. If you remember your factoring, that'll go x minus 5 and x add 2. It'll catch up. Okay. 5 and negative 2. Okay, but be careful. The number that gives a negative log is illegal. Gives a negative log, illegal. If you put negative 2, I'd have a log negative 2 plus negative 2 minus 3 will not equal 1 because these are out of domain. So only answer x equals 5. Let's see. Here, I guess. Chapter 17, 18, 15, 16, 14, 12. Okay, really quick, 2 more. Get my paper straightened out. Here's my 12. Okay. 19. Try to squeeze these in. Solve for x. E to the 2x plus 1 then is equal to 200. Log on both sides. These undo. 2x plus 1 is equal to log of 200. Could punch in the number now. I think I'll wait till the end. See how I'm going to subtract 1. Subtract 1 and divide the whole thing by 2. Minus 1. Yeah, divide the whole thing by 2. So if you want an approximation, put that in parentheses. ln 200, 1 divided by 2, 2.149. And finally, number 20 is 10 thousandths of bacteria colony. According to this, when A is 50,000, so in other words, it's 5 times bigger than the star. This is the start amount, 5 times bigger at 50,000, 5 times bigger than 10,000. Find how long it'll take to do that. E to the 2.1 t, 50,000. E to the 2.1 t. Go ahead and divide by 10,000. 5 equals e to the 2.1. That's 2.1. Log on both sides. Log 5 then equals 2.1 t. Divide by 2.1. And your exact answer is log 5 divided by the 2.1. We'll punch it out. ln 5, 0.7664. All right, I hope that gives you a good start on the final exam review and at least gives you a good idea of what you should be able to do and work for the final. Final exam directions will be coming around by email. It'll be next week. Same format though. But we'll probably have longer questions or be more questions on it. It won't be just 15, more questions on it. But we will pass out those details to you next week. So hope that helps your final exam review. Promise we're all worked in order except for number 6. We worked that at the beginning. Have a happy Thanksgiving.